Hello, this is Sean Mullery from Electronic Engineering at IT Sligo, and what I'm going to cover in this lesson is a look at the counting of the rising edges on the least significant bit of port A to put the different sequences of lights for the Christmas tree lights program out on the port B. Now, this is an exercise that I've already asked you to do, but you may have done it differently than I've done it here. So I have used the method that I showed you previously, where the chase sequences are done fully within the function using for loops. The reason I've done that is I want to show you a particular issue that could occur because of the length of time that we're inside in these for loops here. So what I'm going to do, or what I have added to the program, the Christmas tree lights program, is that I've added this little section here, which again comes from a previous video, where I try and figure out whether the input on the least significant bit of port A has gone from a 0 to a 1 or from a low to a high. If it has, I want to increment a counter. Now the thing is that because I've only got 4 sequences, I only want the count to go from 0 to 3 and then go back to 0, so that it can go through the sequences again every time it gets a rising edge on that least significant bit of port A. So what I've done is if we've determined that there's a rising edge, and if count is not equal to 3, in other words, if it's not at its upper level, I just increment the count. If, however, it is equal to 3, then what I do is I put it back to 0. So that deals with that situation. So count is going to go 0, 1, 2, 3, and then back to 0. What I then do is, unlike previously where I just used the value of port A in my switch statement, what I'm going to do in this case is I'm going to use the value of count in my switch statement. So if it's 0, 1, 2, or 3, it's going to call the correct function. So let's have a look at this operating. Okay, so there it is operating. Now at the moment the count is 0 and the input on the RA0 is also 0. Because the count is 0, we're running the first chase sequence, which is that they are all just switched on. Now if I do a rising edge on this, change it to 1, we can see that I've now changed to the second sequence. If I go back to, in other words, do a falling edge or bring it back to 0, it should still stay on that sequence. Count should still be equal to 1. And we can see that that is indeed what's happened. Okay, I'll move to the next sequence here, which is go to a rising edge. Okay, and then we'll go back to 0, and we'll see that it should still stay on that second, so in other words the third of the sequences, but sequence number 2 rather than sequence number 3, where it's going to it's traveling up to the most significant bit of RB and then going back to the least significant bit and traveling up again. Okay. Now, one of the issues with this is that because of the length of time that is spent in the chase, chase 2 and chase 3 in particular are quite long functions. Chase 3 is twice as long as chase 2. And because of the length of time that you're staying in there, what could happen, particularly with all these delays, is that during that time we could get a rising edge, and then it could go back down to a 0 level, in other words, falling edge, without us ever getting back to the while loop for us to actually check has a rising edge and a falling edge happened. Now, normally speaking, when a person, a user presses a button, that because it's a human being, they're going at an awful lot slower of a pace than the microcontroller can go. But when we have functions here that have delays in them and can go on for a considerable amount of time, it can happen. Okay, so what I'm going to do is I'm going to show you this changing from a 0 to a 1 and back to a 0, and hopefully prove to you that I can stay on the chase 2 sequence. Okay, so change to a 1 and change to a 0. And there I go. And you can see there that I've stayed on the chase 2 sequence because I did it quickly enough that we never got back to actually check if that had occurred. Now that's a little bit of an issue that I want to solve in the next few lectures, because I want to use a thing called interrupts. And interrupts are something that once the rising edge occurs, it will immediately stop what it's doing and go and deal with that situation and decide what it is we want to do. So that's what's going to occur next. Just to prove to you that this is still working, that it's not just a bug, if I hit the rising edge there and I wait for us to get to the end of this sequence, we should find that we're now in the sequence of chase 3, and there we are indeed. It's starting to go back down again. And I can go back to a 0 edge. So what has occurred is that in the previous case, we did the change too quickly for it to take account of it, and therefore it missed the actual edge happening. Now, if you did the problem the other way, in other words, the previous way that I had done it with the static variable in there, and with it coming back to the while one loop after each movement, the chances are you wouldn't be quick enough with the key to actually get this to occur. So that's why I wanted to show it to you in this style of a one.